All right, Math 121, here we are again with exponentials and logarithmic functions and their graphs, all right? So here's our exponential function, this black one. So this is a new guy for you guys, this e here. If I type it in up here, this is called Euler's constant. See this 2.71828182, blah, 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 blah. This is exactly like pi. It's an irrational constant, okay? So we call it Euler's or Euler's constant, depending on what continent you're living on. So I tend to say Euler's. This is called the natural exponential function, all right? It is an inverse function of this guy, the red one, which is the natural logarithmic function. What I want you to see is this inverse function relationship. So now there's this line, y equals x. See this big thick red line here, y equals x? Well, you can see that what I have here is these two have been kind of folded over this line. So that's exactly what an inverse function relationship is. It's where y equals x. So, for instance, in the black function, I have this 1 for my y. So this is the y. So if I want this red function to be the inverse, then I make the y the x. So look at here and notice that the y of the black function is now the x of the red. And the x of the black is the y of the red. So we're literally saying y equals x. We're flip-flopping the variables, okay? So that's what inverse functions are, is you literally say, hey, if the x was this, its inverse, that will be the y instead, okay? This is cool. So a lot of things are the same. So like that critical point I was pointing out that we have to know anyway, and you're going to see that we have to know this because we're going to move it around, right? But it's doing the same thing with the asymptotes. So you'll see in my blue graph or my black graph, I have the black graph here with the blue asymptote at y equals 0. So y equals 0. Well, y needs to become x, so then when I go to the inverse function, x is now 0 instead, right? So everything just flip-flops, x and y. That's what inverse functions are. Okay, I want to talk about moving these graphs around a little bit. So just like before, if we add something to the end of a graph, we slide it up. So what we did here is I added 2 to the end of the function, and it slid all the y's up. So this y used to be 1, now it's 3. So now you can see why we need to know where that point is. But also, my asymptote was y equals 0. Now it's been moved up 2 to y equals 2. Okay? When we move the logarithmic function, same thing happens when we add the 2. When we add the 2, the function moves up. It was at 1, 0. Now that critical point becomes 1, 2. So the x didn't change, but the y did. Notice that my x equals 0 asymptote, this green line, did not change. It did not move because when we add a constant, we only move the y, right? So the weird one is when we mess with the input. So if I take this graph and I come up here to where the x is, that's where you'll get, like if I minus 2, well, remember, if I mess with the x variable, I always do the opposite of what I see, just like absolute value functions were. So I was at 0, 1. Instead of subtracting 2 here, I want to add 2 to the y. So instead of 0, 1, now I'm at 2, 1. Okay? But notice that the y asymptote did not change, right? We didn't move the y when we did the x transformation. Okay? So when we do the logarithm, though, and we go in here to the input of the function, and we subtract 2, we again do the opposite. So notice that this whole function moved over 2 spots to the right, but so did the asymptote, okay? Because it was an x asymptote, so now the x also has to move, okay? So the bottom line here is when we're graphing exponential functions, you need to be really careful with the y because the y is really weird, okay? And so I like to do this x transformation first and then try to see where that y goes, okay? When you're dealing with the log, you need to be careful with the x because the x is what's weird, right? Because they're inverse functions. So if the y is weird, then the other, it's the x that's weird, right?